So this is the syllabus of computer aided engineering subject for the Pune University. The second experiment in the list is truss analysis using 1D element. Okay. So you can perform all these experiments using any FEA commercial software or open source software. So today we are going to conduct this experiment with the open source software Lisa 8.0, truss analysis using 1D element. So first we will go through the example, truss example. So for the bar truss shown in the figure 2.11.8, determine the nodal displacement, stress in each element and reaction at support. Take modulus of elasticity as 2 into 10 raised to the power 5 Newton per millimeter square and cross-sectional area of the truss member as 200 millimeter square. The length of the first element is 400 mm. It is along x-axis, and length of the second element is 500 mm. Okay. The 12 kilonewton of node is applied at the node number 2. Length of the element number 1 you will have to calculate because the x and y axis distance is given. Along x-axis it is 400 mm and along y-axis it is 300 mm. So now we will solve this example in the Lisa 8.0. So here you can click on the new button. Then in the left panel you can select the analysis type by clicking on the first option, right click, edit. Okay. So 2D, then static 2D, and click on OK. So in the left panel you can see the components and materials. So select this components and materials, click on the node button. So the first node is at 0, 0, 0. Here at the origin I will create the first node. A red dot will appear on the screen. So now the second node. So with reference to the question, the second node is, so here in the user coordinate system, this is the x-axis and this is y-axis. So along x-axis we are moving minus 400 and along y-axis we are moving 300. So here I will enter the 300 mm. Click on add. The second node is added on the screen. Then third node, for the third node just move along x-axis with 400 plus 500, which is 900 mm. Click on add. So now close this button. So now you can click on this screen and zoom out with the help of middle mouse button. So all the three nodes appearing on the screen. Node number 1, 2, 3. Now from this main tool options, select this new element. Click on this new element. Select the beam truss element, line 2. Okay. So now first select the node number 1, node number 2. After that node number 2, node number 3, and click on close. So the two elements, element number 1 and element number 2 are created, connecting the three nodes 1, 2, 3. Now right click on this default two elements in the left panel and click on assign new material. So first here again we will take the circular cross sectional area. So the cross sectional area given in the numerical is 200 millimeter square. So with reference to this 200 millimeter square, the diameter is calculated as 15.93. So with reference to this cross sectional area 200 mm square, the diameter is calculated as 15.93. We will take it as 16 millimeter. Then under the mechanical tab you can enter the mechanical properties of the material. Young's modulus is given as 2 into 10 raised to the power 5. So here you can directly enter 2 raised to the power 5, 2 into 10 raised to the power 5, 2e5, then Poisson's ratio as 0.3. Click on close. So now with reference to the example, there is a fixed support at node number 3 and 1. So what I will do, I will select this node, select the node number 3. First I will select node number 3, select phase. In the left panel, right click loads and constraints, new fixed support. I will repeat the same procedure for node number 1. Select node, then select the first node, select phase, then in the left panel, right click loads and constraints, new fixed support. OK. The fixed support symbols will appear at the node number 1 and 2. Now a 12 kilonewton load is applied along minus y axis at node number 2. Again select nodes, select the node number 2, then select phase, right click loads and constraint, new force. Here along y axis minus 12,000, minus sign for the downward direction, minus 12,000. OK. So here an arrow appears in the downward direction. Now right click on the solution in the left panel and solve. So now you can check the displacement along x-axis, displacement along y-axis, and displacement along rotation about the z-axis. So all these values you can see in the table. So double click on this table in the solution part and click on all update. So the displacement along the answers are here you have got the exact answer with reference to the solution provided for the numerical in the book, and the stress values you can check. Longitudinal stress 199 and 88 values, megapascal, Newton per millimeter square. Then here you can close this window, click on the solution and animate. With the default values you can play the animation. Here you can see how the deformation is taking place when a 12 kilonewton load is applied at the node number 2 and node number 1 and 3 are at the fixed end. I hope that you have understood this experiment very well. Thank you very much.